Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
We've done it. We've done our first image classification in QGIS using the Dzetsaka classification tool. Okay, so that's number one of 6 possible tools that we're going to use. Okay, so we've done the Dzetsaka, we've looked at the images, we added the images or the results via unique layers report to Excel, we compared the classification, dynamics, etc., etc. Okay, so we've done that. So further to that, remember in the Dzetsaka, here I can't pronounce it, Dzetsaka, in the Dzetsaka. Sorry for my pronunciation. I'm terrible with this. So yeah. Anyway, there was these other options that we said we're going to do at a later stage, which is now. So confidence map, save model, save matrix. So let's run these as well and see what the results or what the outcome of these options are. Okay, so I'm going to rerun all of the image the classifications. Okay, so using this NUT, love the word, we're going to run all 4 of them again, as what we did in the previous video tutorial. But this time we're also going to do the associated confidence map, save model, and save matrix. So we're going to run these 3 things as well for each of these 4 methods. Okay, for each of these 4 methods. So go back to my stack raster, my Sentinel stack raster with all 12 bands, 11 bands, sorry, no, 12 bands. My training file with this classes and training samples are still exactly the same ID. So all these things are the same. All I'm doing now is I'm just adding confidence to it. So I'm generating the same image as previously. I'm just saying it's called confidence. I'm just adding confidence after the tool. And then in this case, I'm just saving it as well as the same thing. KK confidence map, KK model, KKN matrix for the K nearest neighbors. And then again, the names that you give them, the file names, that's totally up to you. Okay, there I don't have an issue with that. Okay, so we press perform. Now, so I've run this because some of them do take a bit of time to save time and not pause and start and pause and start. I've already done this. Okay, so which one should we start? Previously, we started with the Gaussian. Okay, I'm just going to leave it there K because all these things are K. So we'll just run with the Gaussian first. Remember to make sure all your names are correct, etc., etc. Run it, and this is the results that we find. Okay, so there's our Gaussian classification. Okay, remember that's how it looks just after it's run or presented. We go to properties. Remember, we're going to load in style. We're going to load the style that we've already saved, generated. So I'm just going to click load the style. Okay, close, and that close. And that should be exactly the same as the original version. You see, small differences, but plus minus the same. Very similar. Okay, so very, very similar. Almost immaterials here and there, 1 or 2 things that's different. So let's click on the confidence one. Let's keep that. And then we're going to say the confidence map. Now, what is the confidence map? This is what it looks like. Okay. So if we expand it, you'll see the confidence map is from -100 to 100. Now, the confidence map, okay, indicates, as you rightly see there, where 0 is where it's totally wrong and 1 is where it's perfectly classified. Okay, so what it basically means, it takes the actual image, the daytime image, our Sentinel daytime image, our stacked image, and it takes the image classification, and it then says, okay, according to the Sentinel daytime image, there should be urban areas. Well, it's classified as veld. That's wrong. Or it's indicated in the daytime image that it is agriculture. In the image classification, it's classified as agriculture. That's correct. So it compares what we've classified and the actual image itself. And then it basically gives us a number whether it is um, correct or not. Okay, so let's have a look at that. So that's our confidence map. By the way, our confidence map is based on 50%. Now, I've just left it as 50%, but ideally, I would think it should be should be about 80%. Okay, so I omitted that to change to 80%. I've left it at 50%. So in the when you do it, just make sure that I suggest using 80%. But again, do 50%, do 80%, and see what the difference looks like. This is basically trial and error. There's no golden rule that says it has to be this or it has to be that, etc. It's basically trial and error until you find the parameters that, according to your analysis, is most accurate or most reliable. And again, that I think would depend on your region of interest and. So let's quickly go through the confidence map. Right click, I go to properties. I go to palette at unique values and I say classify. And there's all my options. Okay, it gives me a large range of options. It's all different colors. Let's just press OK and see what it looks like. Now the green we're not interested in. So immediately we're going to take the green away. So I highlight the green, minus. We're just going to go from 17 to 100. Let's see what that looks like. Okay, so that green part is all gone. Now the blue, let's have a look and see what does the blue mean. The blue is, again, these colors are all over the place. So let me rather do the following. Let's go and do single band. And let's basically just equal interval. Let's make it I'm going to delete this one, delete that one, delete that one, delete that one. There we go. Only this green to red, and say apply. And there we go. Now, why is it giving me that green background now? Properties, because I need to say clip outside, and I won't want the green there. Minus, and go up, and there we go. So the dark red is where it's 100% aligned or where it's 100% fine. So let's quickly, I'm just going to move it below this. So the green there, you can see it's agriculture, and that's correct. And then let's see where this place here, this is not agriculture. Urban. Remember, urban is red. Let's have a look, and you'll see it indicates there's a problem. Confidence map is not, so let's make it a little bit more. Let's give it, what color shall we give it? Let's give it something to that effect. Let's give it this. Okay, so I'm just changing the color ramp. I'm just going to do the inverse of the color ramp. Something to this. Let's apply. Okay, so the red is where we have fairly good confidence, and the other colors is where we have very little confidence. You can see this area is wrong, and well, it gives say 100% confidence. So, but you can see that there is significant areas where there seems to be mismatches. So this is how you present the confidence map. Confidence map. Okay, I still have an issue with that. Not sure whether we present the confidence map Let's go quantile. See, it gives this -100, so let's say apply. See, it gives it basically brings in these ones. Okay, but it's gonna stay roughly the same. I don't think it's gonna change that much. Um, so we don't want this, let's say continuous. Um, apply, and see what that looks like. Um, it comes back to the same type of so we can basically also do a unique layers and see how much according to this is not fitting. Okay, so let's look at the save model. So we're going to go to our file, which is, I'm just going to quickly go to my files. So we're going to go to image collection, and now we need to just going to go sort by date modified. There's our model. Okay, we can't open the model. The model we can only open in QGIS. So let's have a look at our matrix. So what is happening in our matrix? Sorry, this is KNN. I want the Gaussian matrix. Let me quickly go, just close this one. We want our Gaussian matrix. See what the numbers there is. So let me just quickly first just put it into CSV format. So we're going to go down, text and eliminate it. It's a comma. And we're going to say finish. Let's go home. There's a matrix. To be very perfectly honest, I'm not 100% sure what this means. Some sort of matrix. So there is the I1s. All the others are zero. So that makes sense. But what is this one and what is that one? Columns prediction. Oh. Oh. So this is 1, 2, 3, 4, 5, 6. So this is classes. And that's 1, 2, 3, 4, 5, 6 classes. So this big one is, it's number 3, which is, it's felt. So this must be water felt. Anyway, we'll figure that one out at some point. But for now, I have to plead guilty in that I'm not too exactly sure what save. If you want to save the model, okay, now for further use. Now, what is that now? I don't want to save the model with another image. Okay, let's have a look at the random forest. I'm gonna just go to the random forest model now. Again, with these ones, confidence map. And see, let's say this confidence map. Let's see what this one looks like. So we also go this one, classify. Yeah, it's not gonna work. So let's quickly go single color scheme, same thing, classify, apply. So that's the, so let's have a look. What did we use down here? Properties. It is the, let's invert it. So it's the same. Okay, there we go. Sorry, I just want to make sure I've got, for visualization purposes, it's continuous, classify. Okay, 1, 2, 3, 4, 5. Okay, so let's see if we can make sure this is exactly the same. 1, 2, 3, 4, 5. It looks exactly the same. Classify, apply, and there we go. Okay, so that's the random forest confidence map. That is the Gaussian confidence map. Looks very different to one another. The random forest is definitely much more accurate. So that's what I'm saying. The Gaussian thing seems are suggesting that it's most accurate. I don't think that's indeed the case. This, okay. So let's look at the support vector machine. We're going to go to properties. And we're going to go to multicolor, peer zero, say same. And we're going to say apply. And that is it. Look at that one. Oh, okay, sorry, I must invert it. Come on. I'm going to invert it, apply. I'm going to say that looks very. So that is the confidence map of the support vector machine. This Gaussian thing doesn't make sense to me at all. That makes no sense given that it seems it's a worst performing one. So according to my visual inspection, the Gaussian is a worst performing one, but it's indicating it's got the least amount of errors. That's what I'm saying. It doesn't make sense. Let's go k nearest neighbors. Let's go that one there. Single band. We're gonna invert it. We're gonna classify it, and we're gonna say apply. And there we sit. So that's the confidence map of the k nearest neighbors. That's the confidence map of the support vector machine. That's the confidence map of the random forest, and that's the confidence map of the Gaussian. Now, as I said, the k nearest neighbor. Okay, so let's have a look and see k nearest neighbor. There we sit. So let's have a look and see k nearest neighbor. The classification itself. Let's go and have a look and see. We're going to load the style. See where there's if we can pick up anything interesting. We're going to open at some point. Oh, okay, load style. Close, close, and okay. And let's quickly cook, and that's KNN. See if there's again also some differences, but not much between just running the, and that I think is because of the split. That's why there's small differences between, because remember when we ran it originally, we didn't split it. It was 100% used for the image classification. Now we're using only 50% for the image classification. The other 50% goes to the confidence map. And that could be the reason why there's these slight differences between our confidence classification and our non-confidence classification. I'm just using confidence and non-confidence. I hope you understand what I'm saying. So if we, okay, so let's identify a location. So, okay, so remember, if you look at the confidence map, brown areas is where there's a significant difference. White is where they're not too sure. And red is where it agrees. Okay, so let's have a look and see. Okay, you don't want to go in we can't go in that detail. It doesn't want to, yeah. So let's do something which is a bit more straightforward. There's green. So the confidence map. So there's my image class is green. So there's an area where there seems to be, yeah, you see, there's the problem area, and there it sits. See that classified. That's why it's supposed to be agriculture, but that's something is, you can see there's an issue there. So all these places where you have this anomaly, which we didn't properly put this in a class. It didn't know where to put this. Now, what is that? Let's quickly have a look and see what is that. Okay, so this is also sort of mixed agriculture, mix between soil and veld and agriculture. So mix between veld and agriculture. So it struggles to classify that. So the error there is a classification error, not because it was the tool itself, because we misclassified it in our training file and our training sample in our classes. You can see there as well. So a lot of these mistakes or errors, if you want, is because we did wrong classifications. We didn't properly classify these classes. You see, there's this. This was this cloud. So this was this cloud area that that we missed. Lots on the mountains, which is understandable because the mountains do have veld and it does have green areas, etc., etc. Water. Let's water. These issues. If you look at that, they classified as green, but they're not actually green because you see it's not actually green. It does have some green. You see there's some green, but it's again a mixture. It's more like a wetland area. It's between a veld and agriculture again. That's why these errors. So again, we should create maybe a class that sort of captures. You see there's that clouds. And that's why you have those errors there. You'll see the errors that it's on these clouds. We should most probably create a class within our training file that captures the difference between agriculture and veld. Because it seems like a lot of the error relates to that. Have a look and see. There we go. Have a look at this. What is this area? Again, this difference between the green and the veld. See, this is the veld and the green. You've got this in between. So if I take that away, you see again this in between. It's not soil veld, it's not green, it's sort of in between. And that is what it seems to struggle in anyway. See if the SMV, no, same. And the forest, again, same. So it seems like these places where the in confidence map here, you see this goes on, I don't trust. It says it's accurate, but it's for sure, well, it is accurate, but it says there's red areas here, which is problematic. It's not going to work. So, okay, so that is the beauty of many of these classification tools is that you can actually generate confidence maps for your image classification to give you not just a visual inspection of the accuracy of reliability. Why is it giving me a zero, a black background there? Oh yeah, we haven't done the color scheme. Okay, let me save there before we go. So the beauty of this is not just that it do the classification, but it also gives you a confidence map. Now, one have to question the accuracy of the confidence map, but assuming that it has the same errors for each of these classification images, then it gives you still a reliable value, not to say whether they are actually accurate or not, but just to say which one is more accurate than which one, for lack of a better term. So that definitely is, and you'll see that most of these tools have the associated confidence map as well. So when you run the image classification, also run the confidence map, because the image classification, you can visually then basically indicate or interpret the accuracy reliability of your image, but you have the confidence map to give you some backup and to give you some data and statistics that you can also then interpret the accuracy reliability of your image classification. And another thing that's important here is the issue of, you'll see the issue of classes. To correctly specify your classes and to correctly generate your samples, your training samples for each of these classes. Remember, we're doing the image classification based on its spectral reflectance. So each class must have their unique spectral reflectance. Otherwise, you're going to confuse the classification. And you see this coming out there, that we have a class which is sort of in between veld and agriculture. And that's where many of our errors are located. And that is simply because of, it could be just the image were collected in that period, transition period, let's say from seasons, where we go from some of the areas being felled to where it becomes green because of the rains, etc., etc., etc. So there could be valid reasons for this misspecification. But again, put a lot of emphasis on your classes and your samples for each of those classes. So have a look at that. And then, yeah, there we've gone. Let me just save it. We've generated our first 4 images. We've compared our first 4 images, generated our first image classification, 4 image classifications. Let me be net just correct there. We generated our first 4 image classifications for our region of interest based on the Sentinel 1st of September 2024 daytime image with including all 12 bands. And we've generated the associated statistics per class, and we generated the confidence maps. And there we go. So that is Dzetsaka. So next up, we're going to look at which method we're going to do second, and then obviously we're going to compare those. We're going to use that tool to compare with the Dzetsaka tool, etc., etc. Okay, so stay tuned. Thank you for joining me. Much appreciated. Keep that comments coming, and please, 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 please like, subscribe, share the video. Let's get the channel going. Let's get it out there. Let's make it happen. And stay tuned. I'll see you on the other side.